Good afternoon, everyone. My name is Daniel Pfeiffer. I'm the social sciences editor at Choice and the editor of LibTech Insights. On behalf of Choice and LTI, I'd like to welcome you to today's program, AI Speech to Text in Practice, Lesson for Library Workflows, Testing, and Evaluation. Today's session is part of LibTech Insights, a library technology content vertical from Choice, which I'll talk about more in just a minute. But before we get started, I'd like to point out just a few features of the webinar software. All attendees who join the presentation are automatically muted and your cameras are off, so you don't have to be worried about generating noise or feedback. We've got that taken care of for you. In the main area of the screen, you can follow along with the presentation materials. To adjust the size of the shared screen or video, use the divider in the middle of the screen to resize the slides to your liking. We are using the Q&A feature today. Please use it to submit questions or comments for our speakers. We'll answer as many as we have time for at the end of the presentation, so please type them into the Q&A module as they occur to you. You can also use the upvote feature to highlight questions you'd like to see addressed. Also, there is closed captioning available for today's session. To toggle the automated captions on or off, please use the Show Captions button at the bottom panel of your screen. You can also turn on automated translation for the captions by clicking on the arrow button, toggling on translation, and selecting your preferred language. Please note that we are recording today's program, and everyone who registered should receive a follow-up email with the link to the recording as well as today's slides. Before we jump into the presentation, I'd like to just take a minute to talk to you about LTI. So LibTech Insights, or LTI, is a blog from Choice that examines the day-to-day impact of library and education technology on academic librarians, researchers, and students. We cover AI, user experience, accessibility, data leadership, and much more. We're going to drop links in the chat for you to read the blog and to sign up for our once-weekly newsletter with our latest post. I highly encourage you all to sign up. It takes just 2 seconds. LTI has partnered with the Ontario Council of University Libraries for the past year to produce their series, AI Tools for Academic Libraries. In this bi-monthly series, OCUL researchers evaluate AI tools that can be integrated into library workflows. Past installments covered research assistance, metadata extraction, and coding tools. And just yesterday, we ran their newest installment on open-weight AI models. I'm going to drop the link in the chat with the archive of all of OCUL's posts, and you can check them out later. All right, so with that, we are ready to get started. So I'm going to hand things over to our first speaker today, Carrie.
Thanks so much, Daniel, for that kind introduction and for all of the work that you do as the editor for LTI. We're delighted to be here today to talk to you about speech to text in practice and what it actually looks like to set up library-based workflows, testing, and evaluation. I'm delighted to mostly highlight the work of the project team. You'll hear from me the least today. But with us today in the webinar, we have Megan, who's a programmer and analyst in DevOps with Scholars Portal, the service arm of the Ontario Council of University Libraries. Rachel, who is a systems administrator in DevOps, also with Scholars Portal, and Gabby, who is a communications and outreach librarian at Scholars Portal. Who many of you have met already, am Carrie. I'm the program manager of the Artificial Intelligence and Machine Learning Initiative at the Ontario Council of University Libraries. And you'll hear a little bit today from Harpinder, who couldn't be with us live, but has offered some comments as my co-lead of this project. He is the Associate Director of Systems and Technology at Scholars Portal. We also want to acknowledge the work of Carlos McGregor, who was previously the Senior Systems Administrator at Scholars Portal and has since moved on to an exciting new position overseeing AI work at the University of Toronto. So you'll have an opportunity to hear from most of the project team throughout our presentation today. At the Ontario Council of University Libraries, we're really approaching our work with artificial intelligence through a series of exploratory projects where we're looking at how AI might fit largely in already automated workflows. We're very concerned about doing this in ethical and responsible ways. So we're doing this work within walled garden environments, which you'll hear a bit more about, and in one case with an existing vendor that meets our data security and privacy expectations. And we're really looking to learn more about how AI does or does not fit and how it performs within the context of library work. In addition, I oversee a fairly large-scale capacity building program to provide professional development across the province and beyond to library workers on different aspects of AI in our work, and also work to examine the perspectives and needs across our 21 member and small number of affiliate libraries within our consortium. So the exploratory projects include one on extracting metadata from government documents, the audio to text project, which we'll talk about at length today, one looking at how a virtual reference chatbot might enhance or augment our consortial reference service, and another looking at remediation of materials on our accessible content books portal that we provide as a consortial service across the province. So these exploratory projects all are using different AI models or have different purposes, but were identified as places where AI might make sense to examine within existing automated library workflows. So at this point, we're going to hear in just a minute from Harpenter, but I wanted to talk very briefly about why speech-to-text artificial intelligence was identified as a priority item for our exploration at the consortium. So the first is that we have a strong commitment both in our work and in the province of Ontario to accessibility. The accessibility legislation that we're required to comply with in Ontario was at the level that in the United States you're being asked to comply with now or coming very shortly, about 7 years ago. So we have a high standard for accessibility, and we recognize this as an opportunity to potentially improve accessibility compliance of audiovisual materials. It's also possible that doing this makes audiovisual content more searchable and discoverable, which is particularly of interest for things like special collections. And it also offers new and different ways of engaging with collections. So this seemed to be something that was very aligned with benefits that we would like to offer and see. And certainly we recognize that this work could be on a potential scale where doing this consortially would be of potential benefit for exploration. So at this point, I'm going to turn it over to Harpenter, who is going to tell you a little bit about the purpose of the project itself and how we started out with a member-driven hackfest in our exploration of the speech-to-text model that we ended up working with.
Hello everyone, my name is Harpinder Singh and I am the Associate Director for Systems and Technical Operations at Scholars Portal. Scholars Portal is the shared technology service for OCUL, and most of what we take on comes down to a single question. Is this something each of our 21 member libraries should have to solve on its own, or something we can solve once and offer to all of them? Speech to text was clearly the second kind of problem. Our members hold significant audio and video collections, and very little of it is captioned or transcribed. The accessibility obligation is real and it is growing, but manual transcription takes days per item, and commercial per-minute services get expensive quickly at collection scale. Those services also mean sending material to a third party. Much of what our members hold is under copyright, privacy, or donor restrictions, where that simply is not an option. That constraint shaped everything that followed. So the purpose of this project was to test a specific proposition, that we could run an open source speech to text model on infrastructure that we control. and offer it as a service across institutions and produce output good enough for real library accessibility work. That left us with two questions rather than one. A technical question about whether this can actually be operated as a service for multiple institutions instead of run by hand by one person who knows the command. And a quality question about how you evaluate whether a transcript is good enough and good enough for what purpose. The rest of this session is our answer to both. This project started with a single day in a room on February 23, 2024. OCUL hosted its first AI Hackfest at the Sherman Center at McMaster. 35 people took part from 13 out of our 21 member libraries, alongside Scholars Portal and OCUL office staff. The format mattered, not a demo or a webinar. The instructions were to bring your laptop and bring your own audio files. The objective was capacity building, and the room was deliberately mixed. Developers, archivists, accessibility specialists, public services librarians. Participants added projects idea to a shared sheet beforehand, and the range of those ideas is the real finding. For example, Brock wanted Whisper embedded in a web page. McMaster proposed a Raspberry Pi box, plug in a USB stick, it transcribes what is on it, and then shut itself down. Laurier contributed ideas with no code in them at all, asking whether archival donor contracts even permit this kind of processing. Same technology, 20 different institutional problems. One entry on that sheet was mine, and it was a single line: upload files by FTP or globals, download the results the same way. 2 years later, that is essentially how files move in and out of the system we built and tested. The sheet was not a brainstorm, it was our requirement document. The group also spent real time on policy, bias, accuracy, and guardrails, which is the large part of why this project later built an evaluation rubric with human reviewers rather than just a rather than just reporting on accuracy score. And the day produced one concrete outcome. Audio to text was written into the AI ML task force report in May 2024, which turned a day of experimentation into a project with a plan and resources behind it.
So after the Hackfest, the project was, as Harpinder mentioned, written into the task force report that defined the exploratory projects that OCUL would take on. There was then a pause while my position was filled, and project planning commenced in April and May of 2025, though Rachel completed some work in the intervening time on the pipeline that she'll speak to. Between May and September, the rubric was designed and validated, and then we invited volunteer evaluators that you'll hear Gabby talk about a little bit, and completed evaluation and feedback. The technical pipeline was developed and refined. And finally, we were able to close the project in February of 2026. And there is a project closure report available online about this project, which offers more detail, although you'll hear about many of the things that we learned today. So with that, I'm going to pass things over to Gabby, who is going to delve into a bit more about the evaluation process.
Perfect. Thanks, Carrie. So, The evaluation process that we designed here. Oh, sorry, I jumped ahead. There we go. So in designing the evaluation criteria and rubric for this project, we started by looking to some existing assessment frameworks that we could draw from and adapt for our needs, learning from colleagues internationally about what was most essential in terms of priorities and achievements for this technology to really be useful. Most of the existing materials evaluating speech to text tools at this time were designed specifically for medical transcription. So in some ways, this was helpful to us. There's a strong emphasis on accuracy and transcription of some really technical jargon or field-specific terms. But there were still some key differences between our use cases. So, we have instances of multiple speakers, there's background sounds, background music, things like that. So we did do some adapting in order to account for a more flexible measure of success and a wide range of criteria. We decided that a rubric would be the best evaluation format. This would give us a set of established criteria that all subjective reviewer perspectives could be measured against in a consistent way. But it still allowed for, an option to provide additional comments or context at the end of the rubric, and it really allowed for flexibility across categories too, and an overall bigger picture. So it might have been, an instance of it was excellent at capturing punctuation properly, but not so great at line breaks and consistency that way. So it allowed for that kind of flexibility. And the evaluation was really created with future use in mind. This was a test case that we were running, but we were thinking of broader library use cases and how this rubric would need to be designed in order to suit a wide range of materials that libraries and archives might have. So we had a couple of drafts of the rubric that we ultimately ended up using. Carrie created a draft which we then tested against some internal files. We had a video tutorial on depositing data in a data repository, and we had a version of this in both English and in French. So we used both of those versions because we do have schools with bilingual mandates. And then we also used a public domain audiobook file as well. Following these sort of internal tests, we did make some adjustments based on this trial run. We decided we needed to shift the way that we measured things like hallucinations and omissions, whether we were going to consider how many hallucinations were present versus the extent of potentially a single hallucination, how that would be scored against our criteria of poor, moderate, excellent. We also shifted the way that we measured things like fillers. So, we wanted to focus more on consistency of notation of those rather than deciding writ large whether their inclusion was a benefit or a detriment. That's something that's highly contextual, and the larger challenge really would be whether that notation was consistent or inconsistent in the future. We also did have the benefit of having an earlier test case before our rubric was developed and before the official start of this project, where a community event that was hosted by OCUL, it was an accessibility symposium. They approached us about using our Whisper instance to generate transcripts for their event recordings, which would then be reviewed and remediated by a group of volunteers internationally. And so this project did not use our evaluation criteria. We hadn't developed it yet, but their feedback from their experience was really, really valuable as we started to plan out our own work. And we were really fortunate actually to have two of those volunteers from that initial project with the Accessibility Symposium volunteer to be reviewers for this project as well with the rubric that we developed. And this was really helpful to see their experience carry over and to hear from them about how many positive improvements they really noticed from the outputs from this project versus the first one that they worked on. So this was really due to the amazing fine tuning of parameters that Megan did, which she'll talk about in a little bit. In terms of establishing a test corpus, no project is obstacle-free, and we did run into a bit of a challenge when it came to establishing a test corpus for this project at one point. We were really lucky. We had a librarian and a member library approach us with a video and film collection that would have been really fantastic for this use case, providing a variety of material types to run against our evaluation criteria. Unfortunately, a challenge that is pretty common with institutional collections is, of course, licensing concerns and copyright. And for those of you who are joining us from the US today, Canada's Copyright Act is different than the US in this regard in terms of, where there may be some provisions in US copyright law that might have facilitated this a little bit more easily without needing to contact every rights holder for permission to use the materials this way. That wasn't the case for us. And ultimately, we were on a timeline that had to be met. So we had to sort of look for other options that wouldn't have this obstacle. We reached out to the university archivist at the University of Toronto, who was really helpful in providing a selection of materials that wouldn't be subject to these licensing concerns, and we were able to proceed very quickly. So we're really grateful to them for their quick response to that. And then we also used a selection of open educational resources from eCampus Ontario, which were licensed for reuse with additional author permissions as well. These two collections together gave us a really robust test corpus of, I believe we had about 27 recordings. These were a variety of lengths, formats or styles. So, we had some lectures, we had some tutorials, we had some kind of like short film style things. And we also were able to get some materials in French, which was really important for us for testing because, as I mentioned, we do have member libraries with bilingual mandates. And of course, even schools that don't have bilingual mandates will have multilingual collections as well that they may want caption files for. So we're really grateful to everyone who helped with this and contributed for being so responsive, so adaptable, so flexible. And it was a really good learning moment for us as well in terms of bearing in mind additional considerations and timelines for restrictions or limitations of collections to navigate in a project or a service like this in the future, and being aware of sort of what the impact of those might be. So as we moved into the official testing phase with our group of ultimately 10 volunteer reviewers from across our member libraries, we divided the work into two sections. We did half the recordings and then had a group check-in and feedback point before moving on to the rest of the recordings. And we did end up making a few more changes to the rubric after this first round of evaluations as well. These materials that we were working with were really different than anything we've been able to test with previously. And so we did also have more expertise and perspectives too from the volunteers. We had members from our video community, the OCUL video community, from our accessibility community, and from our assessment community. So we had a lot of really great expertise helping with that, and it did give us some more insight on where we might need to refine a few things. We added a couple new categories and refined some of that existing criteria to measure more consistent caption of utterances. So coughs, sneezes, laughs, those weren't sort of things that we thought about before, but actually can be really, really important to the context of a recording. And also to make sure that things like background music or overlapping voices were noted appropriately to assess if line breaks and sentence length met industry standard. And from this feedback and adjustments to the rubric and the evaluation period as a whole, some of the key accessibility considerations that came out of this testing period that were really emphasized as priorities, but were maybe not quite up to scratch yet with Whisper at that time were solidly accurate word-for-word transcripts with correct punctuation and sentence case consistently every time, consistent labeling or omission of utterances, ambient sounds, background music, fillers, things like that, timestamps being really, really essential and needing to be absolutely accurate throughout. If you've ever tried to clean up a transcript where the timestamps and the text are off by like even just 8 seconds, it's brutal. Industry standard for formatting for line breaks is we have it as sort of no more than 2 lines of text for a line break. Really, this is character based. It's based on character count. So no more than 42 characters per line, these being 2 short lines of text before you would need a line break, meaning a new timestamp. And speaker notation, absolutely critical. This is maybe a bit less relevant where you have like a single speaker recording in the format of an audiobook or a tutorial video where that context of who the speaker isn't really relevant to the meaning and the impact of the recording. But where there is more than one speaker, or it's a significant speaker, potentially, differentiation in notation between speakers is really essential. So those were our primary accessibility considerations and outcomes from that early testing phase. And I'm now going to pass it to Megan and Rachel to talk about some technical considerations.
All right, awesome. Thanks, Gabby. And hi, everyone. Rachel and I will be covering the technical side of this project. So you've already know how the overall experience looked like from the user side. But what we want to walk you through now is what we actually had to build behind the scenes to make it all work. So to start with, I want to give you a quick overview of what we built. On the right of the site, you can see 6 main components that made up the system. The transcription model itself is open source, but everything else you see is something we have to develop from scratch. And then to give you a quick idea of what's involved, the system will watch us for new files and wait for each audio or video file upload to finish before it starts processing. And from there, it loads each institution's own settings, detects the spoken language if needed, runs the transcription, and writes out the result in 9 different formats. And if something goes wrong along the way, it handles the failure on its own and keeps going. All of these rounds without anyone manually triggering or monitoring it. And we will go through each of these in more details over the next few slides. And this is a processing pipeline. In other words, this is what happened to a file from the moment it arrived on our server. So first, the institution will upload their audio or video file for Globus, and it lands in that institution's dedicated input folder. The system will pick it up, but it doesn't start processing it right away. It will check the file size a few times first to make sure the upload is actually finished. And we build these validation steps because Globus transfers can take a while, and we don't want to start processing a file while it's still being written. And once the file is stable, the system will read the institution settings file, which is their option.txt, to figure out which model to use, what language to expect, and what quality settings to apply. And then if this language is set to auto, Whisper will listen to the first 30 seconds and will automatically detect the language. Then the actual transcription is run on the GPU. The output is timestamp text, and the system write it out in 9 different caption and subtitle formats. And once that's done, an email report will be sent to the institution with the results. At the bottom line here, you can see if anything fails during the process, the file will get moved back to the input folder. So the system will also remember that it fails, so it doesn't keep trying transcription on the corrupt files. And so before we look at the system architecture and how everything connected, I wanted to quickly go over the hardware and services we use. Starting with the GPU server, we are running on a H100, which is what gives us the processing power to run Whisper model. Because without it, we will be limited to CPU, which means slower processing and smaller, less accurate models. Running FP16 means an hour of audio can be processed in minutes rather than hours. The transcription script and all of the dependency are packed into a Docker container, and that would include PyTorch, FFmpeg, and the caption libraries. Containerization will also keep the app isolated from the server itself. So update, crashes, or any changes to the app will never affect the underlying machine. It also means the environment exactly the same every time we deploy. For storage, we have a network-mounted directories at Globus that holds each institution's input and output folder. The container accesses it through a volume mount, so the data live outside of the container, and nothing is lost if the container is updated or restarted. And then we have 2 external services, Globus for secure file transfer, and an MSTP relay for sending processing reports. And the next slide will show how all of these pieces actually connected to each other. So this is how everything fits together, and I'll walk through it from left to right. It starts with the user uploading audio or video files through the Globus web interface. Globus is a secure file transfer endpoint, so users don't need direct access to the GPU server or the container. The uploaded file will land on the shared disk, which is backed by an NFS server. This disk is then mounted directly into the Docker container, so the transcription script can read and write files without having to manage store itself. Inside the GPU server, the Docker container runs the Python script, which is our main processing application. It watches the Globus directory continuously, and when a new file arrives, the transcription will start automatically. Once it's done, the output are also written back to the same shared disk, and the email server send a report to the user, letting them know the transcription are ready. And now on the right side, you will notice 2 components that are not on the previous slide, which is GitLab and the container registry. So this is our deployment pipeline. Our script will live in the self-hosted GitLab repo. So every time we push the code changes, the GitLab CI/CD will automatically build a new Docker image, publish it to the container registry, and deploy to the GPU server. So we never had to manually build or deploy anything. And one of the design decisions we made early on was to use one shared deployment for all institutions while still giving each institution control over how its own files are processed. So how do we make that work, and how is the file actually used? If you find the transcription quality is not quite right for a recording, where audio has some specific requirement and you want to adjust how Whisper handles it, you probably don't want to change the code every time you need to make that adjustment. And this is where the option file comes in. So you can see the left side is a real example from U of T. Language is set to auto, which means Whisper will detect the language automatically. And then the model is set to largely free. This is the Whisper model we use. And then there are also settings for things like temperature and translation. I'll go through the main parameters in more details over the next slide. But each institution will have its own option files, so any changes made here will only affect that institution. And we also added some safeguard around it, like if a value was missing or invalid, the system can still fall back to its default instead of stopping the whole process. And if the option file is missing completely, the transcript will still can be run using the default setting. And these are some of the parameters that had the biggest impact on transcription quality that I have grouped them into 3 areas. On the left are model and language. So like I mentioned, we use largely free, but there are many more models to choose from. We can either let Whisper detect the language automatically or set a specific language if we already know it. And translation can also be turned on when needed. In the middle is the decoding strategy, which controls how Whisper chooses transcription. Beam search will let it compare several possible results instead of only following one. And the temperature controls how much randomness Whisper allows when choosing between possible words. When it's at 0, it will stay very conservative and go with the most likely result. But if the result is not reliable enough, it can retry at a higher temperature up to 0.6. So it will start with the safest option and only add more flexibility when needed. And on the right are settings that help reduce common errors. There's no speech threshold that helps Whisper decide whether a section actually contains speech. If it looks more like silence, it can skip the session instead of trying to turn on the silence into words. We also turn off condition of previous text, so an earlier mistake is less likely to affect what comes next. And the initial prompt will give Whisper some guidance on punctuation and capitalization with separate instructions for French audios. And I know some of this can be hard to follow because there's a lot of math behind how it works, but if anyone is interested, I had a more detailed document on how we tune those parameters, and I'm happy to share it later. So this is what the system actually produced at the end of the pipeline. From a single transcription, we generate 9 different output formats. We know that different teams will use different tools and platforms, and each one will expect its own format. So we wanted to make sure the output is ready to use no matter what the workflow looks like on your site. The first 5 on the top rows are format that Whisper can generate on its own. The bottom 4 are ones we built on top of that. And then for TTML and SCC, we were able to make the SRT file that Whisper produces and convert it using existing libraries. But for SAMI and rote text, there were nothing available to give us the right output, so we wrote our own code to generate those 2. So we talk about what happened when everything goes well. And then this slide is about what happened when it doesn't. So when a transcription fails, maybe the file is corrupted, or it's not actually an audio file, or Whisper just can process it. The system will do 3 things. It moves the file back to the institution's input folder, and then record what we call a signature, which is the file size, its modification time, and its index node number. And then from that point on, every time the system scans for new files, it checks that file against the stored signature, and then if nothing has changed, it will just skip it. And this is how we prevent the system from getting stuck in an infinite loop, filling on the same path disk over and over. But if a correct version is uploaded, the signature won't be matched anymore. So if the system pick it up, so the system will pick it up and process it again automatically. So either way, whether the file is bad or it gets replaced, the system will handle this on its own. And with that, I'll hand it over to Rachel to walk you through our research and design process.
Thank you so much, Megan. So following HackFest, our team had developed a really promising proof of concept, and we wanted to take this a step further and continue the research and design process. So I'm going to walk you through the technical and infrastructure decisions that shaped our approach. Firstly, we looked at maintainability and feature development. Our original proof of concept was built using a bash script. So for us, it was very important for us to think about the future of this. how can we expand this? We made the decision to redevelop it using Python. This choice was driven by the fact that Python is a widely adopted language used for data processing and data manipulation. OpenAI also maintains an official Whisper Python library, and this is backed by a really large and active community. Lastly, we also have in-house expertise with Python. So gradually and naturally, it turned out that Python was the best fit for our team. Secondly, I want to bring up the fact that we were also approaching this with user friendliness and security in mind. We were looking for a solution that was user friendly and was able to help us with our users transfer their data securely. And our initial proof of concept had no user interface and required us to actually upload files on behalf of the user and kickstart the process manually on the server. So as you can see, this was not a scalable solution, nor was it user-friendly. We also needed to provide a secure environment for users to upload and retrieve their materials. So in the end, we settled on Globus as our secure file transfer solution. Globus itself is built for moving large files securely in a research-grade environment. And rather than relying on FTP or email, users authenticate through the Globus web interface and transfer their files directly to the server. The generated transcripts are then made available for download through the same interface. And one thing to highlight is that Globus is hosted on Scholar's Portal's servers. Therefore, we are keeping data within a trusted infrastructure. The last thing I want to mention is hardware. During Hackfest, the infrastructure that we used was not equipped with GPUs. This significantly constrained our capacity as we could only run Whisper's smaller models. This limits our ability to process larger files. We could not handle multilingual content, nor could we support multiple concurrent users. So to address this, we partnered with our colleagues at the University of Toronto Libraries who helped us source an older GPU machine to use. However, after testing, it became very clear that this machine did not have sufficient compute for our needs. So we moved quickly to acquire a dedicated GPU resource, again, in partnership with University of Toronto Libraries, and we jointly purchased a GPU machine, which is also known as H100, which you would have seen in the diagram earlier that Megan presented. And so access to this dedicated GPU machine has truly been transformative for this project. It has enabled us to run all the largest models for Whisper at greater volume, greater speed, improve the accuracy of transcriptions, and added multilingual support and the ability to serve multiple users and multiple payloads. So with that, I'm going to pass the mic back to Megan, who's going to share some key lessons learned and bring our section on technical considerations to a close. Thank you.
Thank you, Rachel. So I will wrap up a few things we learned along the way. First, there's no single set of setting that works for everything. A lecture recording, an interview, something with a lot of background noise, they all behave differently. And that's a big part of why we built the per institution configuration the way we did. Second, when you already know the language, it's better just to set it directly. Auto detection works, but it's not as consistent. Third, large v3, which is the model we use, give us the best result. But it does take more time and resources, and that was a trade-off we were happy to make for our use case. Fourth, accuracy alone doesn't make the output stable. Punctuation, capitalization, and clean segment boundaries matters just as much. Without those, the transcript is still hard to work with even if the words are right. And then fifth, audio quality ended up affecting the result more than anything we could change on our end. And finally, most of our development time went into everything around the model. The file handling, error recovery, format conversion, and reporting. The model does the transcription, but everything else is what makes it a service. Thank you. And with that, I'll hand it off to Gabby, who is going to take you through the next session on testing additional models.
Yeah. All right. So with wrapping up our project with Whisper, we were considering what some next steps might look like and what a future potential service offering might entail beyond this work that we've done with Whisper. But ultimately, as I'm sure many of you are aware, this area of development is moving so quickly. And so by the time that we started testing with Whisper, there were many newer models with different features available. And we knew that it would be important to compare our experience with Whisper against other speech text tools. as the technology continues to evolve. So we decided to choose 2 open source models and 2 proprietary models for this comparative testing, though we did use only sort of the free open out of the box versions for the proprietary models. And these models were chosen based on a survey conducted by AI for Lamb, speech to text interest group. So we used the same files that we initially used for our testing with Whisper before our test corpus. So going back to that data deposit video tutorial in both English and French, the audiobook as well, but we did primarily use that video tutorial. And then this allowed us to look back at some of those outputs from Whisper in direct comparison with the outputs of these additional models. So the 2 proprietary models that we tried were Assembly AI and DeepGram, but again, only using those free versions. So some of the advantages and disadvantages of each of these models is laid out here on the slides. One advantage to the proprietary models like these is that they do offer a sort of browser-based playground kind of out of the box, which really beneficial for anyone, but especially for teams who may have limited either technical infrastructure, resources, or expertise or capacity in this area. In terms of Assembly AI, it offered a credit limit model for accessing certain customizations while using the free version. And these customizations included things like text summarization, redaction, speaker identification, translation, sentiment analysis. So had a really excellent range of features, but implementing them with the free model is tricky because adding those features uses up those credits very quickly. But many of these advanced features were not offered out of the box with Whisper and required further development and configuration. So having these options available right away was a benefit for sure. A challenge with Assembly AI was file size and audio length limits that were in place, which can be challenging for longer materials and would require manual chunking for better processing. In terms of DeepGram, their free tier level of service also offered customizations, diarization, smart formatting, sentiment analysis, again, redaction, detection of utterances or even topic detection. And these features were also not available just out of the box with Whisper. So here too, there were some great customizations available, but were limited based on the amount of credits used. And upon exhausting that initial sort of credit allowance, continued access to those features did require adding a payment method and moving to a pay-as-you-go billing approach. Limitations for both of these models was largely their data handling practices, and that those were significantly less secure than we would have liked. Both required that data was sent to third-party servers, whereas with Whisper, that allowed the transcription of data sets within a local environment. So that was really important to us as an infrastructure service provider, really valuing locally hosted infrastructure and data protection for our members' data, and in this case, in this context, their collections as well. But the free tier offerings for both of these models did necessitate the transmission of data to third-party infrastructure or require data to be publicly accessible for processing. So that definitely poses challenges for projects or materials that are subject to copyright, privacy, data governance constraints, which was also why we only used sort of our initial testing materials that are ours alone in that initial video tutorial that we used there. Okay. And then next for the open source models. The open source models that we opted to use were Canary and Granite. Some advantages with these models included better data handling practices, speed. They were faster at processing than Whisper. They had really strong punctuation and capitalization formatting with Canary specifically, and Granite had a really wide range of languages available. These were locally hosted models like Whisper, so they also then adhered more closely to our preferred data handling practices that would better align with projects subject to copyright and privacy concerns. Limitations, again, included that larger files would require chunking manually to process properly. And there were either no or comparatively poor performance indicators with French materials compared to Whisper for those. But in terms of Canary specifically, the transcription quality we noticed degraded quickly for longer audio files. This was something we noticed with Whisper as well, but we were able to sort of work around that a little bit more with some fine tuning. This was largely because for Canary with the training data, it was limited to a maximum of 40-second segments. Canary did provide timestamps, but they typically reflected time intervals per audio chunk. So again, going back to those sort of 40-second segments. And the model didn't support word level timestamps. So these ended up with having like really extremely long caption lengths. They were not really functional from an accessibility standard. They definitely didn't meet that 42 character limit. Whereas in comparison, Whisper allowed timestamps at a segment level, word level, or both. So it allowed for shorter timestamp intervals and more natural transitions and sentence flow to be captured. And Canary was also much more stringent about file formats than Whisper was. So again, requiring chunking for better processing, and it didn't have native multilingual translation functionality, whereas Whisper did. For Granite, Whisper and Granite both offered a broad range of language support, English, French, German, Spanish, Portuguese. But in our testing, we did find that Granite processed French files more slowly and with more errors than Whisper. This is likely due to the fact that we did more fine tuning with Whisper over time, particularly for French files. And some identified issues included like prompt text appearing in some of these transcriptions. So you might have a line that said, "This is English audio," or "does not translate verbatim words," as well as things like improper noun errors. It didn't quite capture or reflect the context that something might include. So data verse as service name was transcribed as data base. So there were some issues like that. Like Canary, Granite also required audio chunking manually, and it did struggle with speaker changes too, and word insertions and other forms of degradation over time. So it was really exciting to explore both of these models, but in terms of open source models, we did have much more success with Whisper, though that was largely due also to the amount of time that we spent on those models. So from all of this testing with Whisper and then looking at a few additional models and comparing them, we obviously learned a lot along the way. It was a really helpful process that was allowed us to see what was really feasible with Whisper compared to other models, but also to really take the time to have to identify and refine our priorities and use cases with the evaluation criteria that we created. And it really helped us to get a much better idea of what this project might look like as a longer term service offering if we were to ever do that. What would be required for that, what we still need to do, and where we're meeting those requirements already versus what are some outstanding considerations. So in terms of service improvement potential, at a very fundamental but very important level, Whisper significantly reduced transcription remediation time. We have here on the slide from days to hours. And this was in the case of some test materials, maybe already having pre-existing transcripts that were in terrible condition, a messy Zoom transcript, for example, where if someone had tried to take the time to remediate that, it might have taken them days. With Whisper, it would take hours. But many of these materials did not have any pre-existing transcripts. They're older materials where the vendor didn't provide one, they weren't available, the files may be corrupted. At that point, many older materials in library and archival collections will not have an existing transcript. And so you're really starting from scratch, which means that in that case, you're absolutely saving even more time than days. Building a transcript from scratch is really, really difficult and time-consuming work. So that was really helpful. The fine-tuned model was particularly high on accuracy levels, and we did notice a significant improvement over the course of the project, which was really encouraging. 2 of our volunteers I mentioned earlier, they also assisted in remediation for the project that used our model before our project began, and they both noted that they came in with very low expectations because of the quality from those early transcripts before really any sort of parameter tuning had been done, but that they were really impressed with the improvement since then, and that the quality of the transcripts produced in this project was much higher than they were anticipating, and they could really see a use case for them. So that was really encouraging to hear. And then for our particular use case, but I imagine for many other libraries and consortia as well, having locally hosted and managed infrastructure is really important to us. Being able to have this be a consortial initiative allows us to support at-scale accessibility tools like Whisper for institutions who, have a wide range of resources and capacity, and to leverage that shared infrastructure for a larger collective benefit. And then finally, some outstanding considerations for the future. There, were definitely benefits and improvements, but also acknowledgement amongst our group that human labor is absolutely still required for remediation. There are some elements of this Whisper model that could not provide all the necessary functionalities and features that were identified as important for accessibility. For example, speaker identification was something that was really an outlier in this case. And that was not able to be addressed by parameter tuning at this time. So that was something to consider. all of this ultimately affirmed that there are use cases for this kind of service offering. And I think it gave us a much better sense of what those use cases are and what the limits to those might be, as well as affirming the ongoing value and need for human in the loop approaches to transcript remediation. I talked a little bit earlier about how our experience with licensing and copyright limitations early in the process gave us a better understanding of where this might impact future use cases. But another consideration on top of that will also be data retention policies for the uploaded materials and the transcript outputs as well. And this will involve larger conversations about, governance and rights management processes at both consortial and institutional levels. And finally, documentation. I'm the communications and outreach librarian. I'm all about documenting and having clear communication of expectations, responsibilities, processes, all of that. So we do have some existing documentation for parts of this process that were involved in this project, using Globus for file transfer and things like that. But further documentation will absolutely be needed to support decision-making processes, engagement with the service offering, and things like those retention policies and licensing considerations. So those are all considerations we will continue to have internally and with our member libraries as we review this project and consider future directions. And that concludes our presentation today. Thank you so much for listening. Our resources are listed here, including the rubric we developed for this project and the final project report, though I believe Carrie also dropped a link for that in the chat. And I'm going to turn it back to Carrie now to facilitate the Q&A for any questions you might have for us.
Yeah, so we had a few come in. I just want to highlight a couple that folks have been jumping in and answering. Rachel had asked, just noting that a presenter at the American Sociological Association earlier in the month found that Whisper was very bad at auto transcripts of speakers from certain English varieties when transcribing parole hearings. And he tested several models, and she doesn't remember what the others were, but that Whisper was the worst. And Rachel, you had jumped in and responded to this, which was not inconsistent with our own findings initially, but a lot of the work that you and Megan did made a big difference there. If you'd like to speak to that.
Some of those earlier reviewers from that initial project, I don't want to speak for them, but given the expectations that they came into our project with and the way that changed over time, I think they would probably agree with that was their initial experience with it as well. But having a lot of fine-tuning support over time was beneficial to that.
Yeah. Rachel, did you have anything you wanted to add from the technical side?
No, I think that really summed it up. It's just we had seen that in our initial testing that just using Whisper out of the box, it wasn't enough. To improve the quality of the transcript, we had to refine it further, figure out what parameters could be adjusted. And as I said in the comment, that the audio quality also has an impact on how Whisper picks up the text and is able to do the transcription. So in some cases, some pre or post processing is required, whether it's you have to clean up the audio before you run it through Whisper, or it's you have to generate the transcript and then you have to clean up the transcript with some post processing. So that's something that we noted in our testing and development. If there's any particular parameters that you're interested in, or if you want some suggestions about how you could kind of approach that, feel free to drop us a note, and we'd be happy to provide some guidance there about which specific parameters we would suggest you could look into. Thank you.
Yes, we had a document about how to adjust those parameters. So
yeah. I just want to encourage folks, if you have additional questions, please feel free to enter them in the Q&A. We had an additional question about the automatic language recognition. Jennifer noted, with the automatic language recognition, what happens if there is no spoken language within the first 30 seconds of a video? And what happens if there are multiple languages within a single audio or video? Which was definitely something that we tested and ran into and had a number of conversations about. So Megan, you were able to respond to this one in chat, but if you'd like to share with everyone on the call today.
Sure. So speaking of the multi-language first, that's a known limitation we have tested so far. So if we set English language to English, the whole file will be transcribed in English, even though there's French audio included. Also, If there is no one speaking the first 30 seconds, the way we handle it is it will fall back to the default setting, which is usually English, but depending on how you edit your option files as well. So yeah, but it's a pain point that we have encountered as well.
And I would say in general that we do occasionally, as you know, in a bilingual service environment, we do occasionally see examples, and we did have examples within our test corpus where something was mostly in English, but perhaps in a question or a response to a question in a Q&A in a webinar, it switched over to French, as an example of something that does happen within our environment. So while that wasn't necessarily something we could address, it's something to be aware of. And I think if people know that that's a limitation of the service, that's definitely something that we can advise our end users on. So Jason, hi Jason, is asking, could you speak about the fine-tuning process, and what are considerations about selecting data for the process? So Rachel, Megan, over to you with that.
Yeah, I can speak a little about it. So in our project, we didn't actually retrain or fine-tune Whisper's model weights. What we did was more about tuning the parameters and improving the workflows that Whisper has provided in their Hugging Face, or the official GitLab repo. So, and for data selection, we focus on whether the material represented real use cases and whether we had the right and permission to use it. But Rachel, if you have anything to add on?
Yeah, I would say our data is specific use cases because we had tested specifically multilingual content, and then there was, us going through the process of addressing the copyright, challenges with audio text. So I would say like it's very specific to, I guess, OCUL and Scholars Portal context for selecting data. But if there's something further that you kind of wanted to, know a little bit more about, please feel free to drop us a note if there's a specific type of data, because we did work with audio and video. But if there's another type that you're thinking about, please feel free to let us know and drop us a note.
Okay, and then we have an overall question that I think is a great last question for us to end on, which is, whom is this service most beneficial to? And Gabby, I'm feeling like you might be the best person, but I'm certainly happy to jump in and give my perspective as well.
Yeah, no, I'm happy to. I think it's something that for us, our audience is kind of unique because our main audience who we work with closely is actually librarians and library staff at our member libraries. We don't too often work directly with end users, but some of our materials are shared with end users, and also, librarians and library staff and our colleagues also have accessibility needs, and it's something that I think can get overlooked fairly easily because I think now we think about, oh, well, Zoom has an automatic transcript and it's probably like good enough. And, the context may be there. Or we think about live captions being provided during something, and maybe we don't think too much about the fact that there's a delay in live captions, and so that may not be the most helpful for a recording after because they're not going to sync properly. And older library materials might be completely inaccessible to someone because there is no transcript file for them. The vendor never provided them. They're really old, they're historical collections. And therefore, there's a whole range of incredible material in library collections that are not usable to many of our users and our colleagues. But libraries are so worked beyond capacity already. And I think we're all familiar with, the projects that we'd like to get to, the materials we'd like to make available, the requests that we have coming in to support that. And there's simply not being enough capacity for that, particularly as budgets get smaller and smaller and smaller. And the amount of human hours that remediation creation of transcripts from scratch takes. So I think in terms of who is this most useful to, I would say it's not really a specific answer because I think it is anybody, but I think you can think about it as either, students and end users who are trying to, take a film course or to, in library school, or your colleagues who are doing research on these materials. It's anyone who's looking to interact with these and just making them more broadly available that way. And there are so many materials that aren't accessible in that way right now.
Perfect.
Kind of a
Thanks so
vague
much,
answer,
Gabby. I'm going to hand it back over to Daniel to wrap us up for today.
All right, well, thank you all so much. And thank you for all of you in the audience for your questions and comments. It was a really great presentation. I'd like to remind you that we did record today's program, so be on the lookout for a follow-up email from Choice with a link to the recording as well as today's slides. Also, if you have a few minutes after the presentation to fill out a brief survey, we would really appreciate it. Thanks again to all of you out there for joining us today. We hope you found the session informative and engaging, and we hope to see you again soon on another webinar. Take care, everyone.